Welcome to Ask and Learn.
We're asked to show that the set of strings of the form 1 to the n squared, where n is an integer, positive integer, is not regular using the pumping lemma from exercise 25. So to do this, we'll suppose that the set is regular and derive a contradiction. So suppose that the set of all strings of form 1 to the n squared where n is a positive integer is a regular set. Now, clearly, this set contains arbitrarily long strings, and so by the pumping lemma, there are some strings u, v, and w, v not equal to the empty string, such that the string u, v to the I, w is in the set for each I in the positive integers Now, of course, since this string is being recognized for each I, it follows that v must contain only ones, so it follows that v is equal to 1 to the m for some m greater than or equal to 1. However, then it follows that 1 to the n squared minus m, 1 to the pm, so we have for all positive integers p, we have that 1 to the n squared minus m, 1 to the pm, is in the set. Now 1 to the n squared minus m 1 to the pm is equal to 1 to the n squared plus p minus 1 m. So it follows that n squared plus p minus 1 times m is a perfect square for all positive integers p. However, the difference between successive perfect squares increases more and more, while the difference between successive terms in this expression increases consistently by m. So we have that, for example, k plus 1 squared minus k squared is equal to k plus 1 minus k times k plus 1 plus k, which is equal to 1 times 2k plus 1, which is increasing as k increases, while our expression n squared plus p minus 1 m is linear in p. And therefore the differences don't increase. And so, at some point, one of the elements of n squared plus p minus 1m is not a perfect square. However, this is a contradiction. This implies that our original set is not a regular set.